Hello everyone, how are you all doing? I hope you all are doing good. In today's video, we are going to start with a new chapter, that is chapter number 4, Science 1, Measurement of Matter. Right? Now, in first place, what do we understand by matter? We know that anything which occupies space and has mass is termed as matter. Now, matter comprises of something. What is that? That is nothing but atoms, right? These atoms have mass, right, which will determine the atomic mass as well as the molecular mass. And these atoms are sometimes very unstable. That is why they combine with each other. And when they combine according to the laws of chemical combination. So there are two laws which we are going to study. One law is related to the mass. You have to write it down, please. One law is related to the mass, that is law of conservation of matter. And another law is related to proportion of atoms, and that is the law of constant proportion, right? Here the compounds which are formed, they are represented by the chemical formulae, and they will be written using the valency of the elements. We will come to know what exactly is valency in the further chapters. Okay, now let's start with laws of chemical combination. Now, the composition of a substance changes during a chemical change. We are talking about a chemical change, so there must be a reaction taking place. Okay, the fundamental experiments in this regard were performed by scientists in 18th and 19th century. While doing this, they measured accurately the substances used and the substances which were formed, so that they could compare, right, their masses. The scientists Dalton, Thomson and Rutherford studied the structure of substances and the atom and thus discovered the laws of chemical combination. How many laws are there? I told you two. One is law of conservation of matter, which is related to the mass, and another one is law of constant proportion, which is related to the proportion of atoms. We will be talking about both the laws in detail. Scientists could then write the molecular formulae of various compounds on the basis of Dalton's atomic theory and the laws of chemical combination. Right? Now here in this particular diagram which is shown, you can see the reaction is taking place between solution of calcium chloride and solution of sodium sulfate. Right? Also, the mass which is shown is exactly the same. So once the reaction has taken place, the white precipitate of calcium sulfate in NaCl solution is formed, correct? If you want to write down the reaction, you can write it down. CaCl2 plus Na2SO4 gives CaSO4 plus 2NaCl. Followed, students? Can you know what exactly I am talking about? This particular diagram, there are two compounds which we are using, calcium chloride along with sodium sulfate, right? In the test tube, sodium sulfate is there, and in the conical flask, calcium chloride is there. When you allow the reaction to take place, correct? First we have measured it, right? So it is 300.23 grams. Now once you have allowed the reaction to take place by tilting the conical flask, the reaction will take place and a white precipitate of the salt calcium sulfate CaSO4 will be formed along with a solution of sodium chloride. So this will be CaSO4 plus 2 molecules of NaCl, correct? Now the weighing would be taken place again and the weight will remain exactly the same. It means the mass or the weight has remained the same, correct? That is the law of verification of law of chemical combination. Now in 1785, the French scientist Antoine Lavoisier inferred from his research that there is no rise or drop in the weight of the matter during a chemical reaction. And that is what we saw right now. The weight remained the same before the reaction and after the reaction. So in a chemical reaction, the total weight of the reactants. Students, can you tell me the two reactants of this reaction? Anyone? What it will be? Calcium chloride and sodium sulfate. Na2SO4 is sodium sulfate. CaCl2 is calcium chloride. These are the two reactants. And how many products are formed here? Again, two. Calcium sulfate, that is CaSO4, and NaCl, that is sodium chloride, right? So in a chemical reaction, the total weight of the reactants is same as the total weight of the products formed due to the chemical reactions. And this is called the law of conservation of matter. Means the matter is conserved. It is not lost, right? There is no gain in the weight. There is no loss of weight when a reaction takes place. That is the first law, correct? It is given by French scientist Antoine Lavoisier. Followed. Now, in 1794, the French scientist J.L. Proust stated the law of constant proportions. Now here we are going to talk about proportion. First we talked about the mass. What was the first law? That the mass will not change. Whose mass will not change? Reactants and product. Mass is always same before the reaction as well as after the reaction. The proportion by weight of the constituent elements in the various samples of a compound is fixed. Now this is the statement. Let us study what this statement actually is. For example, the proportion by weight of hydrogen and oxygen in water is 1:8. Now if you would write it down in your book, the formula for water is H2O, correct? Right? So hydrogen's atomic mass is 1. So 1 into 2, that will be 2. And for oxygen it will be 16. Okay? Right? Because that's the mass of oxygen. So because there is only one atom of oxygen, it will be 16. And for hydrogen it is 2 atoms. So it will be 1 into 2. So this means if you have 9 gram of water, correct? Then 1 gram will be hydrogen and 8 gram will be oxygen. How we did that? See, H2 means 2. O means 16. So that gives you total of 18. Correct? Now if you take 9 out of it, it means hydrogen will be 1 and oxygen will be 8. Followed, students? Please refer to the book if you have any doubt, or you can ask again. Similarly, the proportion by weight of carbon and oxygen in carbon dioxide, CO2, right? Carbon will be 12 and oxygen will be 32. Okay, so if you add this will give you 44 grams of carbon dioxide. So if you have 44 grams of carbon dioxide, it will be 12 grams of carbon and 32 grams of oxygen. Now if you again take it into proportion, so what we do in proportion, we will divide. So 4 3s are 12 and 4 8s are 32. So this will give you a proportion of 3:8. Similarly, the proportion by weight of carbon and oxygen in carbon dioxide is 3 is to 8. And in water, how much it was? 1 is to 8. I hope it is clear to you. So what is the statement? The proportion by weight of the constituent elements in the various samples of a compound is fixed. So for H2O it is 1 is to 8. For carbon dioxide it is 3 is to 8. Followed? Now he verified that law of proportion. But now since this is not included in the syllabus, you can just read it, okay, because it's important, right? So many compounds can be made by different methods, correct? For example, 2 samples of the compound copper oxide were obtained, one by decomposition of copper carbonate and another by decomposition of copper nitrate. Okay, what is formed? Copper oxide is formed by 2 methods. One by decomposition of copper carbonate, another by decomposition of copper nitrate. From each of these, 8 gram of copper oxide was taken and each was then treated independently with hydrogen gas. Correct? Means the copper oxide obtained from copper carbonate and copper nitrate, both was treated with hydrogen. So both gave 6.4 gram of copper and 1.8 gram of water. Correct? So then he verified the law again, that the proportion is remaining constant. So how it is remaining constant? Followed? So the reaction of copper oxide with hydrogen yielded 2 known substances, namely water and element copper. So it is known that in the compound water, the elements H and O are in the proportion 1 is to 8. This means 9 gram water, there will be 8 gram of oxygen and 1 gram of hydrogen. Followed, student? And so on. Now if you see, if 8 gram of both the samples of copper oxide contain 6.4 gram of copper and 1.6 gram of oxygen, and the proportion by weight of copper and oxygen in it is 6.4 is to 1.6, that is 4 is to 1. Thus the experiment showed that the proportion by weight of the constituent elements in different samples of a compound is constant. Correct? That is how you can verify the law of constant proportion. Now let us see what the expected proportion by weight of the constituent elements of copper oxide would be from its known molecular formula. We know the molecular formula, right? That is copper oxide. So we know the atomic masses. Copper is 63.5 and oxygen is 16. This means 63.5 is to 16. Correct? So that will be approximately, if you divide, it will give you 3.968 is to 1. And that is approximately 4 is to 1. Then that is why the law of constant proportion is verified. So we have studied 2 laws. One is law of conservation of matter. Another is law of constant proportion. Right? I hope you have understood this well. Thank you, students, for watching the video.